Welcome to lesson 2 in module 1. Before we proceed, you must try the print statement. We discussed this in the last lesson, lesson 1. Do it in Python cell. If you have not done it, don't proceed. It's better to consolidate what you have learned. I'll teach you how to use Python shell as a calculator. Python shell can be used as a scientific calculator. It's very powerful and very fast. So we looked at command line interpreter in the previous lesson. Interpreters are useful to learn the syntax of the language. When in doubt, you consult the interpreter. See, when we learn a language, a natural language, we try to learn the grammar. And similarly, when you try to learn a programming language, you should learn the syntax. See, if you don't speak correct English with right grammar, people will laugh at you. When you don't follow the syntax of a programming language, it will throw error at you. This is the difference. I want to demonstrate a syntax error occurring. I explained to you how to print strings. Suppose I want to create a mistake so that you get a syntax error. I simply type print something in the statement prompt. Then definitely it's not correct. So immediately the Python interpreter through a syntax error. And also it gives some explanation also. Is a missing parenthesis. Not only I missed the parenthesis, but I also missed the quotation marks before and after the string. So you can have a single quote or double quote enclosing the string. So this is how the syntax errors will come when you do not follow the syntax. In this slide, we look at what is the primary prompt and secondary prompt. The primary prompt you already know, that is statement prompt. If you see, we execute the programs in the mode known as interactive mode. Our statement was only one line in the previous program. What happens if we exceed a line? If the statement exceeds a line? The interpreter is good. It inserts 3 dots as shown here. The 3 dots here. You can see that 3 dots. If a single line is exceeded, see we type C out is equal to true, and that's one line. That's fine. That's single line statement. And second line, we say that if cond equal to true, so then the statement is not complete. You see a colon there. If cond equal to true, there's a colon. So when you type next line, print condition is within single quote cond. So when the statement exceeds a single line, the interpreter adds 3 dots to the next line to indicate that it is a continuing line. So what is the statement prompt? Made of 3 arrows, 3 arrow pointers. That's called primary prompt. And the 3 dots is called the secondary prompt. So you can write a few lines like this. We'll keep adding three dots to indicate, to tell the interpreter that this is a continuation line. So the output of this is here, condition is true. See, of course, I won't explain to you right now how the output comes, but try to see this. T of true, the T in capital letters is a Boolean constant. Boolean constants are true and false, F capital again. If cond is true, initially we are assigning true to cond. If cond equal to yes, condition is true, so it will print condition is condition, that is true. If condition is, we have said false here, so true, then if condition is equal to false here, and then next statement if condition equal to true, then it won't execute this statement. So this slide is mainly to tell you that you can exceed the statement prompt to 2, 3 lines or 4, 5 lines, in which case the Python shell adds 3 dots. In fact, we will be using this hash. The hash indicates that this is a comment. What follows that in the line is a comment statement, means it is not executable. You are not giving it for execution. It's only for your information. The two types of comments, the single line comments are preceded by a hash. So whatever follows Python or whatever follows hash will not be executed. It will be treated as a comment. Okay? Let's go next slide. So what we saw, the syntax error in the one slide before, that occurred due to violation of the rules of the language. So you should try to understand the concepts governing the language. When we start learning, we learn the rules of the language. Similarly here, you have to learn the rules of the language. I will be teaching you the rules of the language and every slide. Okay? That is how you become master of Python. So when you type a statement, you read it again and again and see whether there are errors, syntax errors. You can also try to give it to another person and ask him whether it's okay. But these are all strategies to avoid syntax errors. In the previous slide, it gave one. In the previous slide, it gave one hint that missing parenthesis, but it could not find out that you are not enclosed within quote. So likewise, the whatever error message you get, that cannot be complete. So the interactive mode, where you write one or two sentences, one or two statements, are fine to start with. But you have to write program with 10, 15, 100,000 lines. So you cannot do it in the interactive mode. So what you need is called IDE, or Integrated Development Environment. Carrying out programming in interactive mode is cumbersome. Okay, if you write programs in IDE, you can write the code, edit the code, save it, execute it. All that you can do. There are many IDEs for Python. Some of them are given here. But what I'm going to use is the Integrated Development Environment IDE. Okay, this is idle. I'm going to use idle. I'm going to use idle. We download it along with Python shell. You can use any other IDE, but it's up to you to use. But I'll be using all through the course the idle shell, like Python shell, the idle shell, it is in the idle program. So we automatically downloaded idle along with Python shell. I told you when you download, you get two items. One is the Python shell or the command line interpreter. The second is idle. So you want to use idle, select idle, the desktop, and click. You will get the screen as shown here. Okay. So this looks similar. The latest version is still better. The 3.11.1 is still better. So here you see the uh, three three arrow pointers or statement prompt. So you get the statement prompt in idle shell also. So you can use the idle shell in the interactive mode as you use the Python shell. Okay. So we can try the same program of printing a string with the idle shell, and you will get the answer. So idle for interactive programs, you can use it for interactive programs. Of course, in IDE, so we really downloaded it for real long programs. So idle has two components. One is the Python shell, and other is Python editor. It's like a notepad. We can use idle shell in the interactive mode as well as as an interpreter to run, or we can execute program statements also in idle. Type the following statement. Print, same way, see, like we have done in Python shell. Print, working with Python is simple. Same quote, single quote, so it's a string, parenthesis, opening, closing. So you get the answer rightly. Working with Python is simple. That's the response you get. So notice that idle also provides a statement prompt. So both idle and the Python shell provide you with the statement prompt. So thus you have got two sources for interactive programming. What is interactive programming? You type something and see the result immediately. One is the Python shell, the other is idle. On Windows operating system, idle is bundled with the Python interpreter. So, but if you're using any other operating system, you have to download it separately. You can install it separately. But since I was using Windows, so both were downloaded on one go. So the interactive shell of idle or the Python shell are very useful for learning the language through trial and error, and it's really nice for testing our own models. So thus Python provides two tools: programming, idle, and Python shell. You can type the statements in anything, either in Python shell or in idle statement prompt. Print Python in exciting language, you get the answer immediately. Look at the next line. X is equal to 9 star 8. We are in the Python calculator lesson. So you should 9 and 8 will be 72. The next statement, it remembers that. So once you type this, it remembers that. The next statement we are saying x by 2. X is equal to x by 2 means it will be half. 70 by 2 is 36. So it prints here. You give an entry here, it prints 36. Okay. So another experiment you can do any numeric calculation, and it immediately gives a response. You can do any numeric calculation. So in fact, here we are not continuing the statement. That's why the three dot is not. So it's really very interesting. You have to have a feel for it. So now you call idle and see the chevron prompt and keep doing experiments. Here I'm doing a lot of arithmetic operations. You can do all the arithmetic operations. You can add two numbers. You try it, 10 plus 8, it will give you 18. You try 10 minus 8, it will give you 2. You simply got to type it only, like I have done. It can be any large number also. You can multiply 1024 by 1024. You will get it. The most important is 10 by 3. See, when you put a single slash, you can call it, I think you can call it backward slash. When you put a single backward slash, 10 by 3, it means it is float division. It will divide 10 by 3 and give the result as a float. Got it? Suppose 20 by 5, 20 slash by 5, you will get 4.0. Okay? You can also have a double slash. Okay, when you put that's integer division. 10 double slash 3 means it will 10 by 3, you will get 3 point something. In the point 3, it will omit. So when you use double slash, you get integer division. When you use single slash, you get float division. So both divisions are possible in Python. You want to find a remainder. It's called modulus. 10 percentage 3 means what will be the result of, what will be the remainder? When you divide 10 by 3, you promptly get the answer 1. That is the remainder when you divide 10 by 3. So here, of course, there will be integers. So in this slide, I showed you addition, subtraction, multiplication, float division, and the integer division, as well as modulus operation. So far we have seen interactive mode program. Now we'll find out how to do script mode program with idle. You can't do it in Python shell. You can do only with idle. So the script mode programming, what you do is use the Python idle. There is an editor in Python, an idle. You can also use any other notepad also. So you can create a new program. Okay. So in fact, if you look at the top of the screen, you'll get that is file. If it's new, you say file new, then you will get a new file will be open. There you can type the program. Once you have typed it, you can save it with the .py extension. Later on, you want to edit it, you can edit it also. Open the file, then carry out editing, and then you can save it again. Finally, you can run the program. Say Python is an interpreted language. So as soon as you type a line, if there's a problem, it will highlight the error by a beep. So when you write a program and save it and run it, the mode is called script mode programming. Script mode programming. So idle can be used for script mode programming. You can also use any other IDE which we have discussed. So let's take an example program. So call idle from your desktop and say file new. Type all this. Hash means comment. You can write whatever you say here. Then I'm having a print statement. Python is an interesting language. Another print. Python is also a scripting language. You can have any statement. Now just save the file as ex21.py. You can give any name you like. I would suggest you keep a separate folder for Python programs and stay over there. It has some way. Here I have said ex21.py because the program appears in my second chapter and the first program. So that's why I'm calling it like that. Now when you click run, you get the result like this. The file name is, of course, I have in the E folder, ex21.py. So Python is an interesting language. Python is also a scripting language. They both are true. So you get the result. So what we had, we know we had an experience of executing Python or using Python in the script mode. So you use idle for interactive mode programming as well as script mode programming. What are the steps? Recall the steps. So you create a text file. Don't use Word file. Word file will not work. So use a text file in the editor, built-in editor of idle. Okay. So how do you do it? Open a new file, then type it. Save it, then run it. You can press also F5. Run from run menu or F5. Okay. So now you know how to write small programs or larger programs in the idle text editor and then run it. See, we are not doing compilation. So we are straight away running it. But when you type the program, if there is error, the beep sound will come. When you run it, if there are errors, program will not execute. Okay. Now we are going to another interesting discussion on interpreters and compilers. As I told you, both are useful for converting converting to machine language from source code. They are both designed to translate programs written in high-level language to machine code or low-level language. What a compiler does is it translates the entire source code into machine code. If there are no errors, if there is error, it won't compile. On the contrary, interpreters bypass the compilation process. It's only for technical reasons. It will take place, but not visible to us. And Python is popularly known as interpreter language. So it means that the code is translated into machine readable form and executed by interpreter one statement at a time. In fact, Java is also an interpreter language. Perl, Ruby, they also have interpreters. So interpreters, there are advantages and there are also pros and cons for using interpreters. So now let us look at the interpretation process. The program we typed in the text editor of idle and stored it with .py extension, that's called source file. We store the programs we write as a .py extension, which is called source file. And it is compiled into Python bytecode. This is a new term I'm using. The source file is converted into or compiled by the invisible compiler of Python to bytecode. Got it? The compilation is there in the Python also, but not visible to us. The source file is converted into bytecode by the compiler, and you get a file. Of course, you can't see the file with the extension .pyc. .py means it is the source code. .pyc means it's a compiled bytecode. So the compilation takes place internally. We don't know it. Completely hidden for the programmer. So you are more happy actually. So compilation is simply a translation step. And bytecode is a lower level, platform independent, a representation of the source code. See, each machine is different. They have got a different operating system, different processors, and so on. So how this is achieved, how the portability is achieved is, in whichever machine you write the source code, it is converted into bytecode. That bytecode can be transferred to other machines. And that machine will have the interpreter, so you execute it in the other machine. So bytecode is a lower level and platform independent representation of the source. So each of the statement in the source file is translated into bytecode. So the bytecode is executable by virtual machine. It may be in our own virtual machine or a virtual machine another computer. Why we call virtual machine? Because it's not a hardware, it's a software. That's why we call it virtual machine. So the compiler translates the source code into a bytecode. The bytecode is executed by the virtual machine in the computer. The virtual machine is the runtime engine of the Python. It's always present as part of the Python system. So the virtual machine is the one which runs the Python code. So see the steps: source file, then we have the bytecode, and bytecode is in turn given to the virtual machine for execution. So before the interpreter, that is the virtual machine, another name for virtual machine is interpreter. So we are using interpreter very for different things. We call the Python shell as interpreter. We are also calling virtual machine as the interpreter. So basically that's why it has become interpreter language. So the bytecode is input to the virtual machine, which is also called interpreter. So before the interpreter takes over, Python performs three other operations: lexing, parsing, and compiling. Again, it's not visible to the programmer. So once that is done, after all these operations, the outcome is neither a source code nor a machine code. It's intermediate code called bytecode. Okay, the bytecode is generated by these three processes: compiling, linking, and parsing. It happens without our knowledge. The job of the virtual machine is to take this code, the code objects we call it, and convert them into machine code, matching the CPU and the platform and used for executing the program. See, we could have developed the program in, say, machine A, which may be using, it may be Apple computer. So when the compilation, everything is taking place, we get a bytecode on the Apple machine. The same bytecode, you give it a PC with Windows operating system. So the virtual machine here, it converts the bytecode into a machine code that can be executed in the Windows machine with the corresponding CPU or central processing unit. So this is how it is. It's multiple processes, which makes the portability of Python code possible. So we have said PVM is a software. We call interpreter also. We convert bytecode to machine code for given platform, operating system, and CPU. The user can't see bytecode. In fact, you can't see bytecode even if you try. It's hidden by from the user. But the bytecode can be transferred to the virtual machine, the same machine or some other machine. So the bytecode are stored with .poc. Then it becomes executable code after the virtual machine takes over and converts into machine code. So the previous file automatically generated by the Python to improve performance. Its generation automatic. The bytecode is platform independent. It can be executed on any operating system that supports .poc format. The interpreter in the target machine that executes the bytecode after converting it into a machine code that is compatible with the central processing unit and the operating system. Okay, this is how the whole thing works. Okay, now we have come to the end of the second lesson. So try these small programs we are given. I'm going to give you much bigger program, larger program, interesting programs, tough programs, all that. But you travel with me, that's the ideal thing. So whatever we have discussed here, you try it out, you try to use Python as a calculator, okay, so that you are ready for taking the next lesson. That's all for now. Until we meet again, bye bye.